So again, this is actually going to be nothing new. It's going to be a new way to look at our situation. Actually, before this, let's review one more time with how we did the Wall Street bet situation, okay? We had 10 weeks, $550. We had 23 weeks, $777.50, right? And what's the first thing we did? We found slope, right? Because you could. And the slope was 777.50. And you guys didn't all set it up like this first shot, but everybody's like, well, I know that he made this much money in 13 weeks, so each week he had to make 17.50, the slope or rate of change, right? And then you picked a point, and you kind of, most people what they did is they did 17.50 times 10 to get 175 and then took that away to see where you started. Well, that's what the point slope equation makes you do. Right? There's your 175 you saved. You're going to find the difference of that in 550 to say that you're saving 17.50 a week, but you started with, what was it, 375? All right? And that sings. And that's kind of nice because then when you graph it, you'd be like, oh, I started at 375 and it went up 17.50 a week. Kind of nice. It's easier to understand the situation than just picking these two points out in space there. So what's kind of nice on these notes, get these down at the top in case you forgot them. Slope formula. Who can remind me how I have it memorized? How do I have it up in the old brain noggin, Berkey?
So y2 minus y1.
Yeah, but how do I have that up here? Yeah, rise over run. And I'm getting that rise by doing y2 minus y1. And I think that's important because one of the most missed questions on that homework quiz was this equation, and a lot of people had x's where the y's were and stuff like that, okay? If you try to memorize the letters and numbers and it's like not attached to any meaning, it's easy to mix things up, right? Does that make sense what I'm saying there? It's easy to, okay? And then the point slope formula, this one you kind of have to memorize a little bit. Remember, it's derived from the slope formula. Y minus y1 is equal to the slope times x minus x1. Y minus y1 is equal to the slope times x minus x1. Remember, x and y need to stay in there. That's all the ordered pairs on your line forever. And the x and y1, that's any point on the line. Any point works. If you have a choice, pick a nice point. Things with like zeros are kind of nice. Like if you have the option to pick like 0.4 or like 5.27, 6.1197.
10.
Pick that first one that I said that I don't remember what I said now. You got 0.4, pick that one. Okay. Actually, 0.4 would be super easy because you just have the y-intercept. You wouldn't have to. Anyway.
They don't give you enough room
So,
to do this.
on number one, here's the mindset I take. Because, like, on a test, it's not going to be like, hey, you got slope-intercept, do this. Or it's not going to be like, hey, this is standard form, do this. Most likely on a test, it's going to be like, hey, man, what's the equation for this? So then what we need to train ourselves to do is, like, say, what information am I given? And this is good problem solving anyway. So what information am I given here? Molly? Yeah, but what information am I given?
That we have the points.
I have 2 points, right? So thinking about 2 points, what's the only thing we know how to do with 2 points?
We can put it in the slope formula.
We can find a slope. So let's do that. Okay? The slope of these 2 points would be negative 1 minus 7 over 1 plus 3. Y2 minus y1 over x2 minus x1. I'm going to do it on the slope. I get negative 8 over 4 for a slope of negative 2. Now, I'm not done. I like to circle it. This is just like an organizational strategy. Do you guys notice I box final answers usually? I like to circle things in my work because especially as math goes on, there's going to be like multiple steps, a lot of stuff going on. I want my eye to find this, okay? So I like to circle that saying that's not my answer, but I'm going to use it. Eli.
Random question.
Yeah.
But not so random.
So the next thing, now I'm going to, in my head, to go further, I say, what information do I have now?
You have the slope.
I have a slope and I have points. So what should be my go-to for
Point slope.
linear equation? Point slope form, right? If I had like a y-intercept in the slope, maybe I'd do something different, okay? Uh-oh. Sully? I got you, Sully. So I've got a slope and a point. Which point looks easier to mess with? 1, -1 probably?
Oh, we're using.
It doesn't matter which point you use. I'm not going to do it 2 ways every time. Either point works because any point on the whole line forever
Are we
works.
supposed to do 2 points each time?
Well, no, that's what we're given. We were given 2 points. So,
Oh.
endpoint slope form, I've got y minus y1 equals m, x minus x1. I used that point. If you use the other point and you do your algebra right, you're solving for the y, same answer. Just pick whichever point looks nicer to you. All right? I know in this equation up here it has the x1, y1. That doesn't mean you have to use the first point. It works for any point. You choose the point.
That's fine.
Yeah, I mean, you can if you want to, but any point in the slope works. So I distribute. I get y plus 1 equals -2x plus 2. And I isolate my y to get y equals -2x plus 1. Now, what can I always do with my answer with these equations? What can I? Berkey.
Put it into the line. Oh.
Mom.
Test it out with the.
Yeah, I could graph it, but I can test it out. If I slap 1 in for x, y should equal what? -1. So I'm going to put 1 in for x. -2 times 1 is? -2 plus 1? -1. Check. My point works. Cool? You see how I did that?
Wait, both?
Both points will work. You want to test it out? Sure, I'm down with it.
I'll say both numbers.
Let's test this point. -3 in here. -2 times -3 is 6. 6 plus 1 is? That point works too. Both points work because those points are both on the line. Makes sense. Makes enough sense. Maybe it's dollars. Why don't we say that? They're spelled different in case you're wondering. All right. Looking at number 2. I have 2 points. What can I do with 2 points?
A lot of things.
Slope. -4 y2 minus y1 over x2 minus x1. I get 3/9 for a slope of 1/3. That's another thing on that homework quiz. I still had some folks not simplifying the fractions. You got to simplify. Everybody go with a slope of 1/3? I'll let Kazzy pick. Kazzy, which point you want to rock in point slope form? -6, -7, or 3, -4? I don't care which one. -6, -7. So y minus y1 equals m, x minus x1. Okay. I'm going to distribute. I get a 3rd x plus 2. I subtract 7 from both sides. And I get 1/3 x minus 5. But what can I do with this to make sure? Let's check it. Let's check the other point. 3, -4. Let's check it. I'm going to put 3 in for x. Boom. It's going right there. What's 1/3 of 3? 1. 1 minus 5? Boom. Nailed it. So it could be tedious. Let's say you had like homework with 20 of these problems. Checking every single one, depending on the numbers, could be tedious. On a quiz, for sure, check every single one. There's no reason not to, right? On homework, maybe like every other one. Just make sure you're on the right track.
What do you do? Check it. You just do
The ordered pair has to work in your line. So I put in x, make sure y is true. Again, let's do this point. I put in -6 for x. 1/3 of -6 is -2. -2 minus 5 is? So when x is -6, y is -7. That ordered pair is on my line. Cool. Try out 3 and 4 on your own, friends. Let's go after number 3. So everybody, from 2 points, what can I find? I want everybody to tell me, from 2 points, what can I find? Slope. So I've got a y2 minus y1 over x2 minus x1 situation. I've got -5 halves there. Everybody good? Okay. I've got slope and I got points. That should be like point slope form. It's even in the name, right? Plus, this is like the point slope form notes, which is a good indicator of that. But I'm going to pick which point. Actually, I'm going to let somebody else. Victoria, which point you want to rock? You chose 4 negatives? Okay. So y minus y1 equals m x minus x1. If you did the other point, you're still on track to do all right, okay? So I'm going to distribute my -5 halves here. Gives me -5 halves x plus 10. So everybody's equation that used this point would look like this. If you use the other point, you'd have a plus 5 there instead. Okay? And I'm subtracting 6 from both sides. And I get y equals negative 5 halves x plus 4. I'm going to test out the other point. I'm going to test out 2, negative 1. I slap a 2 up in here. I get a negative 5 plus 4 is negative 1. It checks out. It's on point. All right, let's do this last one here. The only thing I can get from 2 points is slope. Y minus y1 over x minus x1. I get a slope of negative 1.
Yes, sir. Yes, sir.
Which I'm gonna let Whit pick the point. Which point you want to use, Whit? Y minus y1 equals m x minus x1. I need to distribute my negative 1 and get everything on the same side. So I get y equals negative x plus 7. I'm going to check it. I'm going to check it with this point, the 2, 5. If I plug 2 in for x, I get negative 2 plus 7 is 5. Let's go. I want to look at number 5 with you because a lot of times we get task-oriented, right, versus concept-oriented. And if we were to get concept-oriented, there should be a point here that kind of sticks out to you for a reason. 0, negative 5. What is this point?
Oh, it's your slope.
Nope.
Oh, no, it's not.
Good guess.
No, it's not.
It is your y-intercept, right? So if I have y-intercept and I want to end up with a slope-intercept form equation, what's the only other piece of information I need? All I need is slope. If this is the goal, I have this. I only need this. Why don't I don't have to use the point slope form equation because I already have that point, the y-intercept. You could use the point slope form equation and it's going to work out. It still works because it works for any point. But let me just show you what's up. I can just find the slope, negative 6/8, a slope of negative 3/4. And if the directions say write a slope-intercept form equation, I just needed negative 3/4 x minus 5. I don't have to use the point slope form equation. So do you see how this right here is that concept-based approach? What information do I have? Now, some people went ahead. Did anybody go ahead and do this? Yeah. And if you use the point slope form equation, did it work? Yeah, it works. But this is easier because all we have to do is find slope and we have all the information for slope-intercept. So taking that like hurry up and don't do anything approach, but think, what information do I have? How can I use it? You could save yourself some work on something like this. Max.
So, if this was on a test, would we get marked out if we didn't use?
No. All right. You'd get if it said, here's 2 points. Write the equation of this line slope-intercept form. I don't care how you do it. Now, if you don't have an intercept, the only way you're going to do it is finding the slope and using point slope. But if you're given an x-intercept, could you do this? No, because slope-intercept form only uses the y-intercept, right? So sometimes, I don't want you to get in cruise control and be like, okay, I did this on all the other problems, let me just do it again. It'll work for your homework tonight, but on a test, right, that other way might be easier. All right, Charlotte, which one's the hardest one? 11. Okay, 11 gave us the y-intercept, though. So on 11, what's the only other piece of information you need? Slope. Okay.
Oh, 100%.
What's another number you're thinking about, Charlotte? Second hardest for you.
Probably the hardest. Or 7.
Oh, I was hoping you didn't say so. All right. I'm joking. They're all the same to me.
They're all just the same amount of
Okay. So I don't have an intercept here. I have 2 points, everybody. What can I find with 2 points? Slope. y2 minus y1 over x2 minus x1. I got a 16 over 12. 4 goes into both of those. So 4/3 is my slope. I like to circle it so I don't lose it. Okay. Now I have points in the slope. It should be popping point slope form. Use this point. You don't have to, but if you have an option there, okay, use that one. So y minus y1 equals m, x minus x1. Okay, and remember, x1, y1 can be any point. I know, like, if you're finding slope, you might call this one 0.1, 0.2. The x1, y1 in point slope form like this, it can be either any point, okay? So next we're going to distribute 4/3 x minus 4. I'm adding 2 to both sides.
How did you get that 4?
I'll show you. When I multiply by this -3, my numerator and denominator, I can cross simplify. So 4/3 times -3, there's 2 ways to think about it. The way I think about it, where those cross simplify, or
They cancel.
or -12 divided by 3, which is -4. I like to cross simplify before I multiply, so there's less simplification after. Both will get you there, though. All right, what can I always do with my answer?
Check it.
I can check it. Let's check it with the harder point. If I slap a -9 in for x, Molly, let me show you what that looks like. 4/3 times -9. Those simplify to a 1 and -3. So that's -12. What's -12 minus 2? -14. So when x is -9, y is -14, that point works. Cool.